This is section 3-5 continued. We're on page 140, example 2. This time we're talking about infinite solutions with three variables. So again, we have three equations, 4x minus 6y plus 4z equals 12. Second equation is 6x minus 9y plus 6z equals 18. And last is 5x minus 8y plus 10z equals 20. So this system of equations is basically where three planes intersect an infinite number of solutions, like a revolving door. The panels go into the middle and they all connect on the center. Imagine if that revolving door just went to the sky. Okay, so let's talk about how this is going to work. Okay, again, we do the same thing we did before. We need to first eliminate a first variable like x, and then using two equations solve for the second variable, and just whittle it down and solve for each variable. So the first thing we're going to do is take the first and second equations. So we have 4x minus 6y plus 4z equals 12. 4x minus 6y plus 4z equals 12. And the second equation, 6x minus 9y plus 6z equals 18. Okay, so we're going to eliminate our x's. And so we have a 4x and a 6x. And we need to ask ourselves, what do we need to multiply our first equation by and our second equation by to get to be able to eliminate that? Okay. So what is the lowest common multiple of both 4 and 6? Well, that's 12. 4 goes into 12, 6 goes into 12. So we need to then multiply the first equation by 3, because 3 times 4 is 12. So we'll go ahead and do that. So we get 12x minus 18y plus 12z equals 36. Then the second equation, we have a 6x. So we need to multiply the entire equation by 2 to get a 12 as our x value. So when we do that, we get 12x minus 18y minus 12z equals negative 36. Sorry, I forgot to say that we're multiplying by a negative 2. So we get negative 12x plus 18y minus 12z equals 36. Okay, so when you're looking at this, you go, wait a minute. We have our first equation now is 12x minus 18y plus 12z equals 36. And our second one is negative 12x plus 18y minus 12z equals negative 36. So let's do our addition. We have 12x minus 12x gives us 0. Negative 18 plus 18 gives us another 0. Plus 12z minus 12z gives us another 0. Equals 36 minus 36, again, is 0. So we have 0 equals 0. And this equation is always true. So no matter what we put in for our variables, we're always going to get a true answer. So hence the infinite number of solutions. Whatever we put in will work. Okay, so we know that's true for these first two, but then we have this third equation we have to take into consideration. So we have to then throw that third equation into the mix. So let's do that. So we're going to take equations 1 and 3. So our first one is 4x minus 6y plus 4z equals 12. And then we're going to take our third equation is 5x minus 8y plus 10z equals 20. I just line those up one under the other. Now we have to do the same thing. We're going to try and So we're going to solve for our z variable. We have a 4z in our first equation, and we have a 10z in our second. So let's find the lowest common multiple of 4 and 10, and that would be 20. So 4 goes into 20 5 times, 10 goes into 20 2 times. So we'll multiply our first equation by 5 times 5, and what we get is 20x minus 30y plus 20z equals 60. Okay, so the second one. Now, we want the z's to drop out, and we have a positive 10. So let's multiply everything by a negative 2. See what happens. So we have negative 2 times 5, which is negative 10x. Negative 2 times negative 8 is a positive 16y. And then we have negative 2 times 10z gives us minus 20z equals negative 2 times 20 gives us a negative 40. Okay, now we're just going to add these and see what we get. So we're starting left to right. 20x minus 10x is 10x. Negative 30y plus 16y gives us negative 14y. 20z minus 20z is 0 equals 20 minus 40. 60 minus 40 is 20. Okay, so if we're looking at this, we have 10x minus 14y equals 20. But there is a greatest common factor here of 2. So we're going to divide it by the greatest common factor, take it down to its lowest terms. So what do we have here? So we have 10x divided by 2 gives us 5x minus 7y equals 10. And so we know that this plane intersects the other two. The other two are on the same line because we have an answer of 0, 0, 0, 0. So we know that there is infinite number of intersections because this one worked. We didn't get a no solution. So this one, we would say the answer is infinite solutions. Okay, so now let's talk about what if we have no solutions. So this is again on page 140. We have 3 equations, 6a plus 12b minus 8c equals 24. Second equation is 9a plus 18b minus 12c equals 30. And the last one is 4a. My mouse comes back. There it is. 4a plus 8b minus 7c equals 26. All right, so we have to eliminate a in the first 2 equations. So we just take those again. So we have 6a plus 12b minus 8c equals 12. And the second one is 9a plus 18b minus 12c equals 30. And if we're going to eliminate our a term, we have to find the lowest common multiple of 6 and 9. And so that would really be 18. So our first equation, we need to multiply by 3. So we have 3 times 6a gives us 18a plus 36b minus 24c c equals 12 times 3 is 72. Now our second equation, we have 9a as our first term. So we're going to multiply that by a negative 2. So we can just add our equations. We have negative 2 times 9a gives us negative 18a. Negative 2 times positive 18b gives us a plus 36b. Oh, sorry, a minus 36b, minus 36b. Negative 2 times negative 12 gives us a positive 24c equals negative 2 times 30 equals 60. Okay, so now let's add our equations together. We have negative 18a minus 18a gives us 0. 36b minus 36b gives us 0. Negative 24c plus 24c again gives us 0. So we think this is on the same track as infinite solutions. But then let's look at the right side of the equation. Now we have 72 minus 60, and that gives us a 12. So on the left we have 0 equals 12, which is not a true statement. So there are no solutions. We don't even need to continue on because we know that those three planes are not going to intersect. So this is a no solution because 0 does not equal 12.